Good day everyone, I am Arjuna Nispakli, the first speaker of Group 8. Our group will be discussing all about the concrete pavement. To start off with my discussion, I will be talking about the Portland cement. Portland cement is a combination of limestone, marl or other calcareous materials, and clay, shale or like argillaceous substance. For masonry units and other precast goods, as well as for walls, culverts, floors, sidewalks, tubes, reinforced concrete buildings, tanks, and reservoirs. There are five types of Portland cement that can be used. We have type 1 or 1A. It is when the specified properties of the other four types are not required, and type 2 or 2A to moderate action or where moderate heat of hydration is required. Type 3 or 3A, it is for high strength concrete. Type 4 is it is for low heat hydration, and type 5 is it is for high sulfate resistance. There are also chemicals that they use when making a Portland cement. Tricalcium silicate C3 is, dicalcium silicate C2 is, tricalcium aluminate C3A, and the tetracalcium alumina ferrate C4AF. Next is the composition and the strength. In table, the types of cement 1 normal, the compound percent tricalcium silicate C3S is 50, dicalcium silicate C2 is 24, tricalcium aluminate C3A is 11, and the tetracalcium alumina ferrate C4AF is 8. The compound strength normal Portland cement concrete percent 1 day is 100, 7 days is 100, 28 days is 100, and the 3 months is 100. And the modified, the C3S is 42, C2 is 33, C3A is 5, and the C4AF is 13. The Portland cement concrete percent 1 day is 75, 7 days is 85, 28 days is 90, and 3 months is 100. There are also characteristics and behavior of Portland cement. Depends upon the quality of concrete, the underlying subgrade, and the base course. Concrete is a strong in resisting compression load acting on it, but considerably weak in resisting tensile stresses. It acts as a beam, resisting on a weak subgrade and base courses, and also weak in carrying heavy load associated with impact forces, and it also expands contract due to temperature changes. It expands when it is wet and contract when dried. After pouring, concrete shrinks as the mortar hardens and the cement hydrates. Concrete pavements changes in length with time of day for being exposed to different elements of weather changes. There's also consideration in concrete pavement design. 1. Pavement slab was designed as plain concrete beams. 2. Transverse cracks on the concrete pavement cannot be avoided. With the reinforcement, cracks on the slab will be confined to weakened planes joints spaced at 4.50 to 6 meters distance. B. Vertical offsetting across the narrow crack will be prevented by aggregate interlock or by dowel bars. C. With simply reinforced slab, cracks will only appear at weakened plane joints spaced at 12 to 20 meters intervals. Hair cracks to be held tightly by the steel between joints. With continuous reinforcement, transverse joints are omitted. Hair cracks are checked by the steel and develop at close intervals. E. Faulting is countered by aggregate interlock and steel bars. And 3 is longitudinal cracks on the pavement is slab more than 1 lane wide is inevitable. That is, pavement slab is supported by foundation that deflects when loaded but recover when the load is removed, assuming that the foundation materials are elastic or like a dense liquid. Next is that we will be defining deterioration. As you can see on the picture, deterioration of concrete pavement is due to stress brought about by load, moisture, and temperature. Next is distortion. Distortion is a vertical displacement of concrete slab at the joints or cracks. Distortion is due to failure or weakness of concrete joints. Next is faulting. For faulting to occur, there must be free water on top of the base course and pavement deflection across the joint due to heavy axle loads. Faulting is the result of pumping tremendous force or load that develop under pavement. Then we have also the causes why faulting occurs. These include loss of slab support and erosion of sub base. Next is cracking. Cracking can take many forms in concrete pavement that could be the result from applied load, temperature, or moisture changes. There are two most common cracks like what you see on the slide. We have corner cracks. Corner cracks associated with excessive corner deflection and transverse cracks associated with mixture or temperature stresses or poor construction methods. There are also distortions of concrete. This includes distortion and cracking, like what I mentioned a while ago. And disintegration occurs in the form of durability cracking, scaling, or spalling as the result of mixed design or construction related problems like durability cracking results from freeze-thaw action, descaling, a network of shallow, fine hairline cracks which extend through the upper surface of the concrete. This is the result from deicing salt, improper construction, free-throw cycle, or steel reinforcement to close the surface. C. Spalling is the breaking or chipping of the point edges. It is the result from excessive stresses at joint, weak concrete, poorly designed or constructed joints. Changes in temperature and moisture content. Curved slab curling, flexure stresses, and overall lightening and shortening of the slabs. Changes in the temperature of concrete can cause cracking. Like what I've said earlier, as the concrete gets hotter, it expands. As concrete gets colder, it contracts. We also need to control the cracks, which, if the joint opening is considerably small from 0.03 to 0.04 inches, the projecting aggregate is considered tightly caged, and when the edge of one slab deflects due to loads, the adjoining edge will also be forced down. If the coarse aggregates are weak, as when the joints open so wide, the aggregates interlock is considered ineffective as a means of load transfers. Dowels can be painted, greased, or coated with asphalt for almost one-half or of their length to break the bond with concrete, allowing the dowels to slip within one of the avotting slab ends. Joints are slanted 60 cm in each 3.60 meters length from the normal position. Next is the transverse joint. Expansion joints provide space allowance for the lightening of slab due to expansion to relieve the stress on building materials caused by building movement. Recommended dimension of dowels for concrete pavement joints. The table shows the different thickness of pavements and its recommended dimensions. For the pavement with 15 cm thickness, the recommended dowel diameter is 20 mm and the length is 0.45 meter, and for the spacing meter is 0.30 meter, and so on. As you can see on the slide, there are different joints such as contraction joint weakened vertical plane caused by a groove that was ripped, molded, or tooled into a concrete slab. By controlling dimensional changes in the slab, it controls where cracking occurs. Next is expansion joint. Expansion joint is an assembly designed to hold parts together while safely absorbing temperature-induced expansion and contraction of building materials and vibration, or to allow movement due to ground settlement or seismic activity. Another is longitudinal joint, to control the location of cracks that might otherwise form due to the restraint or temperature and moisture related movements. And lastly, construction joint. Construction joint is the interface between concrete placements intentionally created to facilitate construction, and I will discuss it further in the following slides. Since in the 1940, the concrete pavement provision for expansion joint at interval of 30 meters or less was almost universally practiced in a road building. Studies of more than 5,000 blow-up samples, and it was found out that blow-ups occurred mostly in mid-afternoon at a temperature above 90 degrees Fahrenheit during a period preceded by varying amount of precipitations. Next is the longitudinal joint. Longitudinal joints are provided between adjacent traffic lanes. Hinges to provide edge support but allows rotation between the slabs. Flexural stresses that might cause irregular cracks along the length of the road are relieved or neutralized. Longitudinal joints cannot be considered a major problem under following assumptions. 1. No big load transfer across it. 2. Expansion and contraction movement develop across the pavement width is very small. 3. When lanes are constructed at different time using side forms, the joints are provided with K way in the first slab to accept load transfer. 4 is for longitudinal joint, deformed tie bars are used because the purpose is to hold the slabs tightly together rather to allow the joints to open and close. 5. The diameter and spacing of tie bars are based on the force needed to pull the narrow pavement slab over the subgrade to the joint. 6 is the length of the tie bar is determined from the embedment inside the concrete necessary to develop the strength of the bar. And these are the recommended tie bars for longitudinal joints in concrete pavement 3.60 meter length with in table the type and grade steel grade 40 the working stress is 30,000 and the pavement thickness 15 centimeter. In half bar diameter, length is 60 meter and the maximum spacing is 1.20 meter. In 5/8 bar diameter, the length is 0.75 meter and the maximum spacing is 1.20 meter, and so on. And lastly is the construction joint. First, if concrete pouring will be interrupted for quite some time, that cold joint will be inevitable. The practice is to provide a transverse construction joint. Second, the form tie used to hold the joint tightly close together. Third, should be cleaned and sealed out to prevent infiltration of water to the subgrade and to keep dirt out of the joints. Fourth is materials includes harder paving and air-blown asphalt, sometimes mixed mineral filler, rubber asphalt, and various rubber compounds. They are poured hot and stiff, then cooled. Others are placed cooled. There are some preformed sealant made of strips of extruded neoprene compressed for insertion into the groove joints. The sealant will expand and fill the space completely. That is all for the first part of our topic. My other members will discuss further about the concrete pavement. Thank you.
Good day, everyone. I am Arian J.U. Urbiso. This is the continuation of the topic concrete pavement. I was assigned to discuss about the reinforcement of joints, the subgrade as a subbase for concrete pavement, the concrete proportions, the concrete mixture, the polymer concrete, and lastly, the curing of concrete pavement. First, I will discuss the reinforcement of joints. Jointed reinforced concrete pavement or GRCP contain steel mesh reinforcement, sometimes called distributed steel. In GRCP, designers intentionally increase the joint spacing and include reinforcing steel to hold together mid-panel cracks. So, the spacing between transverse joints is typically 30 feet or more. Steel reinforcement for concrete pavement joints are specified in the design to prevent the widening of cracks produced by the shrinkage of thermal contraction. The reinforcing steel bars are mounted in one layer. along the mid-depth of the slab. The formula used in designing this reinforcement for concrete slab joint is A sub S is equals to LFW over 2S. A sub S is the area of steel cross-section per foot of slab. L is the length of slab between the joints in feet. F is the coefficient of friction between the slab and the subgrade called the coefficient of subgrade resistance, ranging from 1 to 2 with 1.5 recommended by AASHTO interim guide. S is the working stress in the reinforcing steel in pounds per square inch. AASHTO interim guide suggested that working stress from 30,000 to 45,000 per square inch depending upon the type and the grade of the steel. One of the example is the welded wire fabrics. It is used as the reinforcement for concrete pavement made from cold drawn steel wires. So mauna ang naong sa welded wire fabrics, mura siya screen. Based on my research, ara na siya kasagaran makitaan sa slab. Then, ang spacing na niya kay same dyan na siya tanan. The subgrade and the subbase for concrete pavement. The construction standard for subgrade and embankment are precise and almost typical for all pavement types. Under the concrete pavement literature, the undercourse of selected materials is always imposed upon between the subgrade or embankment and the concrete slab. AASHTO interim guides recommend that the subbase must be extended from 30 to 60 centimeters outside the pavement edge to serve as an edge support. The wide acceptance of stabilizing the subbase with Portland cement concrete pavement is due to the investigation result of pumping of concrete slab. Pumping. Pumping is the ejection of water and subgrade soil through the joints and cracks along the edges of concrete pavement. So, mauna siya ang surface sa pumping guys. Kang naay cracks, naay nagbasa na portion sa soil, up to sa kanang naay edge sa concrete cement. With the presence of water on the subgrade and churning it with the soil, it activates the fluid, forming slurry that expel to the surface. So with the presence sa tubig gani guys, kana ganing tubig ara moagi sa kilid sa semento ug sa soil, mag-form na siya og kuan guys, semi-liquid nga mixture, mao na siyang mudangog. Pumping is minimal, where the subgrade have been constructed resistant to erosion by the cement or bituminous treatment, or when pavement slab is underlain by properly graded granular materials. Next is the concrete proportions. The fundamental rule to obtain good concrete is the proper selection of cement, aggregate, and water. Thus, number 1, type 1 or 2 cement is specified for concrete pavement. Number 2 is water for concrete must be clean, free from acids, alkali, and oil. Water that is suited for drinking purposes is acceptable for mixing cement, except water containing large amount of sulfate. Number 3. If the concrete is to be strong, sound, and durable, the aggregate must have similar properties. Number 4. The mineral aggregate of concrete is about 75% of the volume or about 80% of the weight of the normal pavement. Number 5. The maximum size of coarse aggregate is 2 inches. However, the use of larger aggregates, according to some experienced highway engineers, increase its length and durability. Admixture. It is the substance added in the mixing to change the characteristic of mixture. There are varieties of admixtures available like the air entraining admixture, which is very common. Some others, like water reducers, retarder, accelerator, pozzolan, and plasticizer, are also used. Air entrainment. It is the entrapment of air in the concrete mixture in the form of evenly distributed small bubbles. It is used to increase the concrete resistance to surface scaling caused by dicing with calcium or sodium chloride. Another advantage of air entrainment is improving its workability and reduces bleeding in fresh concrete. The effectiveness of air entrainment is to increase the concrete durability that is influenced by number 1, percentage of air present in the mixture, number 2, grading of aggregates, and number 3 is the size and distribution of air bubbles. As mentioned earlier, the strength and the other desirable properties of concrete mixture varies depending upon the ratio of the concrete to mixing water. So durability is dependent on the water cement ratio that should be properly controlled to obtain richness of the paste. Concrete mixture. Considering the high cost of cement, the objective in mixing concrete is to use more aggregates and as little cement as possible, while maintaining the workability necessary for a successful pouring and consolidation. For structural concrete, poured in accessible small areas around reinforcing bars, it is necessary to overfill the voids or spaces around the aggregate and reinforcement using a free-flowing cement in water paste form. Polymer concrete. Polymer concrete could be used alone or in combination with Portland cement to bind aggregates together producing concrete. So, there are three types of polymer mixture, and it is classified into the following. First, polymer impregnated concrete or PIC. The second, polymer concrete or PC. And lastly, the polymer cement concrete or PPC. This is one of the types of polymer concrete, the polymer impregnated concrete or PIC. It is shown in the picture in the surface of polymer impregnated concrete, and it is a Portland cement concrete impregnated with monomer after curing. Also, the polymer concrete or PC is a mixture of polymer, binder, and aggregates. So it is shown in the picture of what is the polymer concrete on its surface. And lastly, the polymer cement concrete or PPC. And it is shown in the picture of what surface of a polymer cement concrete. And it is a pre-mixture of cement paste and aggregate wherein a monomer is mixed before curing. Polymer possesses a higher strength concrete, but due to its prohibitive cost, it is used being limited to bridge deck or repair of small joints. Lastly, the curing of concrete pavement. Newly placed concrete pavement needs curing. Curing may be accomplished by several methods, but basically, all the methods could be categorized into two. First, those that keep the surface constantly wet or covered it with water absorbent material that is re-wetted from time to time. Second, those that pavement evaporated from the water already in concrete, which is retained is sufficient enough for hydration. The chemical action between cement and water produces strength of concrete. So, if the concrete dries out quickly, the hydration and strength process will stop. But when the moisture becomes available during the hydration, the strength gain will continue.
Morning, everyone. I'm here to continue our topic, chapter 8, after the topic of Mr. Orviso. Proceed to topic 13 to 17. First, DPWH specification on concrete pavement. Concrete pavement is categorized under Item 311 of DPWH standard specification, which provides that this item consists of Portland cement concrete pavement with or without reinforcement, constructed on the prepared base in accordance with the plans and specification. So we will proceed to the first one. The material requirements. Only type 1 Portland cement should be used in hydraulic cement. So, Portland na itong gamiton para sa hydraulic cement. So, as a background of this statement, just like our father in civil engineering, John Smithson, he used the Portland cement to build the Edison Lighthouse. Ito, by the concept or the using of the hydraulic lime. And the other one is the fine aggregate. Fine aggregate shall consist of natural sand, stone, screening, or other inert materials, similar characteristic or combination thereof having hard, strong, and durable particles. So, ang mga example na guys, no, kay sand, stone, and other materials from the word fine and aggregates. Pino siya, dito siya, dako. So, we have the fine aggregate table or the breeding requirements for fine aggregates. So, nakaagi naman tag ano, material testing nga subject. So, nakagamit na taag mga save. Save katong murag, lutoanan sa siomay katong circle. So, ang una kay 10.0 mm or 3/8 inches. And the ikadua kay 4.75 mm number 4. And the mass percent of the 10 mm is 100 and the 4.75 mm number 4 and 6 is 9 to 100. So, unsay pasabot ani? So, kung mabase ta sa requirements sa fine aggregates, sa 10 mm pa lang or 3/8 inches, makalusot ang 100. Magbutang ka itong fine aggregate sa babaw sa kani nga sieve. Kung imo siya uyugon or i-vibrate, manglahos tanan sa kani nga sieve. And ang 4.75 mm sa number 4, makalahos ang greater than 95 or equal to 95 and less than or equal to 100% ang malahos. So ano? Ano yan sa 10? The other one is the coarse aggregate. Coarse aggregate shall consist of crushed stone, gravel, blast furnace, slugs, or other approved inert materials of similar character or combination thereof, having hard, strong, durable pieces free from any adherent footings. So, what do you mean by that? So, from the word coarse aggregate, dinagko na siya, no? Lahat man itong fine, kaya gagmay man. Fine, fino, fine. Coarse, dagko. So, and the other one is the water. Water to be used is in concrete mixing or curing or other designated application should be clean and free from oil, salt, acid, alkali, grass, or other substances injurious to the finished product. So, naman nasta sa water stricto man ta guys. For example, kung ang water nimo na oil, so if ang concrete mo gahi niya siya, posible if nag-oil pa to before, na oil sa ilaw, magkabubos-babos to after. And the other example is the salt. So kung magkuha tag water, manay salt or sa dagat ta magkuha, ang posible sa concrete or sa column nimo, ang iya mga reinforcement bar mubuto. Kay kaunon man na sang mga kwan guys. Kaunon na siya sang parat or acid sa dagat. Alkali, and so on. So, ang grass, the other one, kung nasa grass sa concrete, ang water na grass, igsagol nimo sa concrete, ay maglabaw, imo biraw nito, malaos to tanan. So, ang imo concrete na ni agianan sa kanal. So, dapat clean jud siya nga water. So, clean siya nga water, di pasabot nga mainom nga tubig ang gamiton. So, mostly, we will use or the engineer use a water nga nasa gripo or sa katabay. Pwede man mainom pero mahal siya. Nya, it is before gamiton. The other one is joint fillers. Joint fillers should be mixed asphalt and mineral or rubber filler. So sa pasabot ani, joint fillers sa kalsada kung nakay duha ka concrete, isa diri ka concrete, kung ganahan ka imo na siya i-join imo nga isa, mabutang kang joint fillers. Naa siya, it contains epoxy. Okay, we'll proceed to the other slide. The other slide is the storage cement and aggregate. Cement to allow sampling at least 12 days before the cement is used. So, allow ang sample at 12 days before gamiton ang semento. The other one is the water place or waterproof place. So, dapat ibutang ang semento or ang aggregate sa waterproof place or sa dili mo moist siya. Basig siya magtibogol or ang aggregate mag lanay-lanay. Lanay mag basta man na. So the other one is separated size aggregates. So kani i-focus sa aggregate, so i-separate yun ang size. For example, the fine aggregates and the coarse aggregate. So kung ang imo coarse aggregate dinagko na ito nga bato nasagol sa fine, nga gamit nimo sa normal lang nga flooring like sa fish pond kunuhay. So mag tibugol-tibugol na siya, dili uniform ang iya level. Pinamo siya sa gul nga dagko. So that is important to separate the size of the aggregates. So the other one is required qualification of workmen. Concrete batcher. Concrete batcher is a person performing the batching or mixing operation capable of accurate conducting aggregate surface moisture determinants and establishing correct scale weight of concrete materials. So kaning concrete batcher, di naman nato sa disoron, mauni sila ang tabas-tabas sa bato or crush na mapino ang bato or ma-uniform ang iya size or ang iya timbang na pari-pariya. Other one is the concrete technician. The person responsible for concrete production, controlling and testing for quality control, proficient in concrete technology, having sound knowledge and specification as they relate to concrete production shall be. So, sa concrete no, from the word technology, gamit silang technology para to settings of forms. So number one is base support. Base support is the foundation under the form should be hard, true, and grackle so that the form when set while firmly in contact with its whole length and specified grade. So base support no, setting forms base support. So dapat ang iya base kay gahi. Kung tinuod siya through grackle, dapat wala siya space ang ilawom. Kaya in case na naay mga something or earthquake, dili siya madali-dali o crack. And specify the grade. Dapat sakto ang iya angle. Natupong ba siya? So related ni sa number 2 no? Reading and alignment. So form shall be set sufficiently advanced of point and concrete being placed. Grading and alignment. The alignment of grade elevations and form should be checked and correction be made delicately before the placing of concrete. So mo to. Mabutang ka concrete sakto ang angle o natupong siya. Concrete joints are constructed according to type and dimension, location, indication of plans or specification. Provision or joints should be protected from intrusion and injurious parents material after result. Concrete pavement joints are classified into longitudinal joint. So longitudinal joint mostly makita ni nato sa karsada itagas na siya. Tagas siya nga concrete nga duwa. So taas ang iya ang gamiton nga joint. For example, kani ang mga bars. Yeah. Another one is traverse joint. Traverse joint, guys, nagmay rin siya, guys. For example, nagpauga ka o concrete. Imo nagpauga na i-crack diri. Imo rin siya kung traverse joint. For example, i-tape rin nimo ang tunga. I-joint nimo, nakadiyot ra siya. If mauga, pwede na tantangan. Mao na ang traverse joint. Traverse joint is same from this. And same from this. The load transfer device. So the load transfer from the word load, ibalhin, device. So mga device para gamiton ang transfer sa load sa kalsada ni must gamiton, guys. So proceed. Solid contraction joint is made sewing groove in surface pavement is drawn as soon as the concrete hardened sufficiently to permit sewing without excessive raveling and time, usually within 24 hours. Solid contraction joint kani panggabson ang mga contraction joint iguman. For example, kani kalsada, guys, kani naman naging kabilyang maglabaw ikauga sa kalsada or sa concrete ba ni kunuhay panggabson na samok na sa pagianon sa mga tao or sa mga animals. So, sunod, quality control of concrete or quality control and concrete general. Natay ko natay pulong diri ang i-provide sa DPWH. So mamino ta mga igsuon. So ako sa basaw the contractor shall be responsible for the quality control of all materials during the handling, blending, mixing and placing operation. The contractor shall furnish the engineer a quality control plan detailing the production control procedure and type, frequency of sample and testing to ensure that the concrete produced complies with the specification. The supervising engineer shall be provided free access to recent plant production records if they requested in forms with proportionally copies and design, material certification and sampling and resting reports. So mga pulong lagi provide sa DPWH mga igsoon. So, I hope na minum mo ni ug inyo ma-apply sa inyong tagsa-tagsa nga ang nabuhi. So mag-proceed na ta sa last slide. Equipment A, B, C, D, E. So sa equipment, guys, dili ni mga choices mga klase ng equipment na gamiton sa concrete. Letter A for the first one, patching plant equipment. So mao na ni ang pang-process sa bato or pang crushing na dinagko na katong na sila planta na equipment ato na mga machine. The other one is the mixer. Kung man ni kayo ang mixer nga sakyanan na mixer nga atong simple ra atong nang panggamiton sa pagpasa concrete himo. Paving and finishing equipment. Paving masti sa kalsada. Finishing equipment so kanang sample kalsada na second mo nila gamiton ila man ay paligid-ligid sa kalsada para mo plane ng kalsada wala si level lang iya above layer. And the other one is itong mura siyag fork mura siyag tinidor dako ra siya iya ni badlit-badlit sa kalsada para ang kalsada na ay mga spike or mga something rough para dili slide ang ligid o moagi ang mga different transportation. So the last one is equipment forms. Equipment kuno ang gamiton para mo-form ang concrete. So daghan ta kaya na ta mga sample triangle or ang finishing para mo-forma tong concrete dili siya mag kampat-kampat. Sa last na no, limitation of mixing. No concrete should be mixed, placed or finished when natural light is insufficient unless an inadequate and approved artificial lighting system is operated. Ano, wala ko na concrete, ay mix or place, ibutang or finish kung wala tarong nga light unless an adequate approved artificial lighting is operated. Okay, I hope nasabtan na. So, after ani, proceed na ta sa topic ni Mr. Cano. So, by the way, ako din si Molly.
That I will be reporting today. Of concrete is the process volume of voids air to fresh concrete mix, applying mechanical energy. Concrete consolidation is also in the gap between aggregate and the main aim of the to eliminate the air voids from body of concrete. Of concrete is significant of concrete and enhances it also in vibration resistance, liquidity, and helps to minimize creep characteristics. And curing of concrete is defined moisture, temperature of concrete to achieve the desired intended use. Moisture is maintained inside a fresh continue the hydration process. Hardened concrete is called as before curing of concrete. One pasted concrete. About when to start the curing or when we add water in dry concrete, we start immediately and heat concrete. Without concrete will never gain the design. When the concrete is placed and compressed through the surface of concrete, a technical called as bleeding in concrete. Duration of bleeding depends on mixed proportion, concrete compaction method, and so these are not concrete. Fineness of cementation ratio, mixed aggregate characteristics, mixtures added. So this curing of concrete. The oldest and most effective is water curing. Water is moist in this procedure. Curing. Chemical concrete in this type of cure. Sodium silicate is one of the compounds. The use of this compound moistures existing pores to seal the application of this compound should be done. Concrete placement has been complete. When the thin layer of water has vanished, it should be a membrane curing compound on thin water layer. The water absorbed by the concrete break. In most these membrane curing substances, one coat will suffice. A method of curing involves electrics. In this procedure, currents are carried through in the form of plate to opposite concrete sides. Infrared radiation curing strength considerably fast curing. The ultimate affected by the rapid initial. This method of curing is production of hollow concrete. Heaters are located within the. Curing can also be artificial heat while this. Both of these consistent steam curing techniques. The concrete can be boosted by hot water or by through it. When couched during the hydration of cement, it combines with fine coarse and fine aggregately insoluble greater strengths. Members at 93 degrees low or high pressure. In low, roughly 70% of the strength of concrete may be achieved. However, in high pressure, strength can be achieved in only 20. So let's proceed to remove. The removal is called a strike off or strike out only after the time when sufficient strength, at least concrete may be subjected to concrete or the concrete strength affects the form of removal time required for removal and time required during some. So these are the specifications. During strip of the remembered, move until the concrete has developed to support all loads. The time required depends on the structural function, strength, gain of the concrete type of cement, water, cement, curing, and slow concrete. So, connection should be arranged in a way formwork removal easy and simple and formwork panel so that it can Repair. The formwork removal procedure by the engineer to ensure that structural member or from or has minimal defects such as honey, size and shape defects, concrete influence the strength of structure. Repair works can be done or the member. So the separation covers against the hardened concrete wooden wedges being in place until final removal are done. Joists move so that the shores may be removal of joist forms. The shores beginning from the middle of the symmetrically up the from the engineer should be obtained pattern of formwork or. So let's proceed to our method. Slip method in which formwork are chronically as a work process. The vertical construction construct the core wall in construction and stair shafts towers. Formwork is a temporary is used for the flooring of traditional formwork is made glass fiber and some slip type of formwork and it is which is carried up mega structures such as construction of chimneys, roads, construction as well as the word slip, the meaning that is formwork done for the construction of the structure. Form is an advanced construction. The formwork continuously direction for the construction. Slip formwork use of the RCC structure. Formwork is an it can require very less labor in these techniques. Economical, fast, and accurate technique that is used for the construction rise structures. So type cantilever jump from vertical slip form system method, 4 horizontal slip, 5 conical slip formwork, concrete supplier, top deck, truss, yoke, picture. So lastly, the compacted clearance of 5 mm in excess of the specified the payment of asphalt pave represented by the core shall not be in the average thickness is more. So these are the table. Thickness 0 to 5 mm to 0.2 in percent of contract unit 5.0 meter 80 0 mm 72.0 12.2.0 68 and 12.5 meter 57.